So great to be here, and this session is going to be about building applications that work offline just as good as when those applications are online. So let's get started. A little bit about me. My name is Confidence, and I am a human being. You can see what I look like in real life. And during my free time, I like to do physical activities. So something I've gotten into recently is cycling. And the reason why I love cycling is it's one of those rare physical activities you can do and you're having fun at the same time while getting to exercise yourself. So if it's something you guys have been thinking about, you should definitely give it a try. It's really lovely. Then during my free time, I create videos on YouTube. So I have a small YouTube channel where I share knowledge I have about web APIs and technologies and things I've learned as a software engineer. Recently, I've started making content on Rust and WebAssembly. So if that's something you're into or something you're interested in and would love to learn more, check out my YouTube channel. It's just Confident Okoghenun. Then right now, I work at a company called Cloudflare. You can also see I'm wearing the shirt. Traditionally, Cloudflare is known as a cybersecurity company and a content delivery network. But recently, we are providing compute offerings that allow you to host applications just like you can on AWS or on GCP or Azure. So you can build applications that are hosted in our network that is going to be really close to your end users. And what that means for you is that your apps are going to be like really fast. So check out Cloudflare whenever you can. And that's my handle everywhere on the internet. Okay, so let's get into the talk. Who here in the audience has seen this page before? If you've seen this page ever before, raise up your hand. Please raise up your hand and keep it up. All right, I can see a lot of people are familiar with this page. Lovely. If you have never seen this page before, I want to see you raise up your hand. Let's see people who have not raised up, who have never seen this page before. Please keep your hand up. Keep your hand up. Keep your hand up. Okay, I can see some people. So it means these people are the ones with good internet, and they are rich people. So look at them around, and next time when you need a ticket for their first, you should hold these people because they'll be able to afford multiple tickets. But really, this page is something I'm sure all of us have come across, and that's because the internet is very fickle. Like, sometimes we imagine that the internet is always going to be there, but the reality of the situation is that the internet is unreliable. Sometimes we need to get stuff done and we are disconnected and we are left with a blank screen, right? The internet is not as reliable as companies and people would want us to think. But is there something we can do about it? Or are we left powerless to the blank screen and the dinosaur game and we just can't do anything about the experience of our applications when our users are offline? Well, the truth is there are things we can do about it, and that's what this talk today will be focusing on. So we'll be looking at technologies in the browser, techniques, APIs that can help you build applications that work offline just as if they were online. And these are the three things we'll be looking at today in the talk. So the reason we are looking at just three areas is to keep it simple so that you remember as much, and then you can go back home to apply some of the lessons learned in this talk. So the first thing we'll be looking at here is we'll be looking at what the offline first approach is. What is the offline first approach? Then the second thing we're going to touch on is we'll take a look at technologies and techniques for building applications that work offline. And lastly, we'll wrap up by looking at a demo that shows you how to take an application that works only online and will make it work offline. So that's what we'll be doing in this talk. And with that, we can get started. So the big question is, what's the offline first architecture? What does it mean to build offline first applications? For us to understand what the offline first architecture is, let's take a step back and look at what the online first approach is, which is something I'm sure all of us are pretty familiar with. So the question is, what happens when your application is online? What's the experience like? And that is going to help us understand how to build for when the application is offline. So we have a couple of diagrams here. We'll start by looking at the one to the left, to the right, and that's the image of the application being online. So we've all used browsers, right? You open up your browser on your phone or on your computer, you type in google.com, you hit the send button, and that request gets sent. What happens is your browser requests for resources it needs to build the web page. That's the HTML file, the CSS file, the JavaScript file, and everything it needs. And because the browser is connected, there's a good internet connection, it's able to hit the server, which is the cloud you see over there, and the server returns the resources it needs to build that web page. And then you get to see a good web page and everything works fine. But that experience completely breaks when the application is offline. So you lose internet connection, or maybe you lose Wi-Fi connection, or you are out of range or something. Then you open up your browser, you type in the same URL, you hit the send button, but you don't get to see anything. The reason is because that pipe between your browser and the server, that connecting pipe, the internet, is broken. And as a result, your request never gets to the server, and the server never knows what you're asking about, and of course, obviously cannot respond to the question it has not been asked. So you don't get to see anything. But it's possible for us to change this experience, and that's why we're learning about the offline first approach. And that is what you see over here on the diagram to the left. The offline first approach, the idea behind it is illustrated here. And the idea is, instead of having the application only rely on stuff from the cloud, we can have a miniature copy of the server cached inside the browser, such that if the application is offline, as you can see, it's offline. If the device is offline, you can still access the application because you have a cached miniature copy of the application in the user's browser. And what that means is that you don't get to lose work whenever you're offline, or you don't get stopped or blocked just because the application is offline or the device is offline and the user cannot connect to the internet. So it means we can build resilient applications that work when they are online, and also when they are offline, they work just as well. And really, this is what the experience is going to be for your users. So I know we have a number of developers here. This is what the experience is going to be for the users you build resilient offline apps for. So they get to see beautiful apps that work offline, but in reality, the offline app is made up of a couple of technologies. So you have the manifest.json, you have the service worker, you have the cache API, you have the IndexedDB, you have local storage, you have the background sync API, and so much more that come together to help you build experiences for applications that work offline. And if you are not familiar with any of these technologies, don't worry about it. We'll be touching on some of these, so you can go home, do your research, and figure out ways to implement it in your production application. And what you're seeing here is a page called Can I Use? It helps you to see the support for a particular technology. And what this page is saying here basically is that there is great support for building offline apps. So if you take a look at the last two lines of the screen, that's the line here and also the line here, you can see it's almost all green, which means that virtually every browser today supports the technologies that we'll be talking about. Well, excluding Internet 11, IE 11 that has been killed by Microsoft in 2002. So if you have any user using that browser, they might not be able to benefit from it, but no one uses that browser anymore. All of the major browsers, Chrome, Edge, Safari, Firefox, Opera, the mobile browsers as well, all support the technologies we'll be looking at today. So you're sure that you're going home with something you can actually use and something your users can benefit from when you build these technologies into your production applications. All right, so let's start looking at some of the technologies that can enable you build offline first experiences. And the first one we'll be looking at here is the Service Worker API. I'm sure you've heard about it, service workers. And sometimes the word service worker can seem very daunting, like, what does it really mean? But to understand what it means, just take a look at this picture. This is virtually everything you need to know about how the service worker works. The service worker is a router that sits behind your application and figures out where to send requests to. So when your browser, when you type in google.com, for example, and you hit the send button, the service worker figures out where to send that request to. Should I send it to the network? Should I send it to the origin server? Or should I fetch that request from the cache? Maybe it's a resource that has been previously cached. The service worker does the logic for figuring out where each request should go and where to fetch the response or resource from. And like you may have guessed, you write the service worker in JavaScript. So how is the service worker any different from your regular JavaScript file? There are a couple of differences. First, the service worker is mostly designed to do routing. So if your application is trying to fetch an image file, a JavaScript file, a HTML file, the service worker routes between the network and the cache to figure out where the resource is stored. And because it is designed to do routing, the service worker runs on a separate thread. So it doesn't run on the main thread as your application JavaScript file. It runs on a background thread. And what that enables it to do is that the service worker can keep running even though your website or your web app is closed. So the user has closed the browser, it's no longer viewing your site. The service worker can be running and doing background events or doing stuff in the background for your application. So it's a really powerful API, and we'll look at how it works. So this image here shows how the service worker actually works in practice. What you're seeing here is a piece of code you can copy and paste into any application to take it offline, to make it work offline. I'll explain what we're taking a look at here, but just to give you an idea of what the service worker does, there are 3 stages. There's the install stage, there is the activation stage, where it waits to be activated, and there's the running stage. That's the 3rd stage. But really, what the service worker does, like I said earlier, is that it listens for requests. So when your browser is trying to fetch a HTML file or a CSS file, it listens for those requests, and it decides where to fetch that resource from. What the service worker here you're seeing on the page is doing is, it is basically trying to decide if the response of the request you're trying to make has been seen before, and to fetch it from the cache if it's something that has been seen before. But if it has not, it goes to the network. So let's step through the code and we'll talk about what each part does in detail. So here's the fetch event. Whenever your browser makes a request for a GIF, a PNG file, a font, the service worker's fetch event is going to fire. And then what does the service worker do? It runs the cache first function. If you take a look at this function, the function is what? Is trying to see if that request is already in the cache. So remember, the cache is a local copy of the server, of your origin server, but a local copy of the resources that don't change often. So it's trying to see if that request has been cached or has been saved in the cache. If it's been saved in the cache, that if this is true, response from cache is true, it returns that. But if it has not been cached, what the service worker does on this line is that it goes to the network. It goes to make a fetch request, and it keeps a copy of that response from the fetch request in the network back in the cache and returns the response from the network. What this means, in essence, is that for your application, if there's a resource that hasn't been saved in the cache previously, and then the browser makes a request for that resource, when the service worker sees that request, it's able to know to put it in a cache, that is to save a local copy of it, so that next time when the application makes that same request again, it comes to be a response from the cache. It doesn't have to go to the network to fetch that request. And in addition to making the application work offline, it also means that your application experience is going to be much, much faster. Because instead of going into the network to pull out the response, it is actually grabbing the response from the cache, which is going to make it really fast since it has a local copy. So this is the service worker API in a nutshell. And we've seen the screen previously. The reason for bringing it here is to reiterate the idea that there is great support for these APIs that we'll be exploring. So please, please, please feel free to go back home and explore these APIs a bit more, because these are real technologies that your users can benefit from today. Okay, so let's move on to the next API we'll be looking at. And I think it's a good time to take a water break. Who here has a drawer like this in their house? If you have a drawer like this in your house, raise up your hand. I have a drawer like this at home. Okay, I see a lot of people have something similar. I call this the everything drawer. And the reason is obvious, right? There's literally everything in the world inside that drawer. This is what the cache API is in reality. It's an API in the browser, a storage mechanism that allows you to save anything and actually everything inside of the browser. And you might be wondering, like, save what? What kind of things can you put in the cache API? So you can put things like files, HTML files, CSS files, JavaScript files, images, raw responses to requests made by the browser. So you make a fetch request to an API, for example, the raw response can actually be saved in the cache API. So you can put anything and everything into the cache API. It's a beautiful API that you can use to take any application offline. Now, you might be wondering, how is it different from HTTP cache? Perhaps that's something you may have seen in your dev tools when you're looking at the network response. I think the HTTP status code is 304, and the text is unmodified. So the browser has its own caching mechanism called the HTTP cache, but the cache API is provided to you as a developer. It's completely programmable. It means anything that goes in and saved into the cache API is purely detected by you, the developer. And that gives you a lot of control and flexibility into how you build your applications. So what can you save? What can you put into the cache API, and how does it work? This is a bunch of code that illustrates what can be put in the cache API. So HTML files, CSS files, JavaScript files, fonts, GIF, JavaScript files, images, JPG, PNG, literally anything can be put into the cache API. And because the cache API is powerful, the developers who designed the API has made it so easy for you to use. So there are a couple of methods you need to know. Caches that are open, as you can see, the first one on line 2. That creates a new cache. You give it a name. In this case, we're just calling the cache v1. Then the other methods, caches.put. You take a request, you put it into the cache. You have a caches.addAll, which we are using here to add a list of resources. And virtually that's it. There's also caches.delete. So it's a really simple API, but it allows you to do a lot of cool things when it comes to building applications that work offline. And really, because it's so powerful, you don't want to shoot yourself in the foot. So there are best practices that you should know about when using the cache API. I know when you go home to do some self-study, you get to see some of it. But a few of the best practices and techniques to be aware of when using the cache API is that you don't want to cache sensitive information. So things like a user's credit card detail or any sensitive information of that user should not be saved in the cache. The reason is whoever can read the browser cache can see that information, and that could be stolen or lost. You also don't want to save resources that change often in the cache. For example, calls to API. The response to an API call should not be saved in the cache because obviously that's data that is mutated, that changes often. So it wouldn't make sense to have a stale copy of it. But for resources that don't change often, like we saw in the previous slide, static files like HTML files, JavaScript files, CSS files, those are perfect to put in the cache. And we'll talk a little bit more about some of the best practices to have in mind when building applications that work offline. Okay, so let's move on and change gears to see all of this stuff we've talked about. How can you actually start making use of it in your application? Because I'm sure we are developers, we have an application we are working on, perhaps for work or a side project. So how can you take these things we've talked about, these APIs we've talked about, how can you take them and start to use them in your application? So let's look at some implementation strategies to use these technologies and tools that we've seen so far. This is a picture of me at work whenever the internet goes down. Who else does this at work? Or am I the only one? Okay, it looks like I'm the only one. But the idea is that when the internet goes offline, we have an excuse to play, right? As developers, we want to use these APIs not to give other people the excuse to play at work whenever they don't have internet connection. So it's a bit of an irony, but we have the ability to build applications that work offline just as good as when the user is online. So let's start looking at some of these techniques and strategies to implement offline-first apps. The first is using network detection and handling techniques. So the browser has a bunch of APIs to allow you to detect when the network has changed. And if you're able to know that the user has gone offline, you can start to tailor your app to fit the new network condition of the user's browser. So one of such APIs is an expression navigated online, which returns true or false. And that helps you to tell if the user's browser is online or if the user's browser is offline. And then you can start to put your custom logic inside of the if and else statements. But if you would like to add an event listener, there's an event listener version of it. It's the offline event listener. You add it to the window, and when the user goes offline, your callback is going to be called and executed, and of course, that is where you can have your custom logic. So if you can tell that the user has gone offline, you can start to do stuff like this. But really, what can you do in real life? So let's look at how people have implemented network detection and handling in real life. One of the experiences you can provide to users is actually what you saw earlier. So the dinosaur game, the dino game you saw earlier, only shows up when the browser detects that the user has gone offline. And the reason is you want to keep your users busy. You want to give them something to do while they are waiting to reconnect to the internet. So whenever you're using Chrome, for example, and you go offline, you get to be able to play the game and keep yourself busy. Another implementation of this is Trivia Go. So whenever users on the site go offline, there is a puzzle they get to play while they wait to reconnect to the internet. So it's not so useful, right? Because users still have to wait, although they are doing something active, but they are actually not getting work done. But the idea is that it's a dial. It's like you're turning up the volume of a dial, and it's progressive. This is the first thing you can start to do. You can give your users something to do when they're offline, but we can actually do a lot better than this and give them a useful experience. So let's look at some more useful experiences. So this is a screen of a chat application. You can see here you have a banner telling the user that the user has gone offline. So the user has gone offline, is trying to access the application. The user does not see a blank screen or the Dino page. He sees the application. And then there's a banner telling the user, hey, you are offline. We noticed you are offline. And the idea is the user can continue to read messages that they may have missed and draft new messages. And the banner also says when you're back online, we're going to sync your messages so that messages you have queued up in the draft get sent, and stuff that has happened while you are away gets pulled down and you can see the information. So you don't have to, you don't need to let users see a blank screen. With these APIs, you can construct experiences like this in your applications. And it could just also be as simple as something you're seeing to the other side of the screen. It could be a simple banner telling the user that they are offline, so they may not get the latest content, but they can keep reading what has already been cached using the cache API and the service worker API we saw earlier. The other thing you can do is perform synchronization in the background to update the cache whenever there's new content in the cache. And here's an example of an application doing that. So they're reading articles on the Chrome platform status page. And maybe you've been offline for a bit, but because the application provides a good offline experience, you can keep reading stuff. And then you come back online. What is the page telling you? It's saying a new version of this app is available. You should hit the refresh button. So these are experiences you can start to build. If the user is online and then goes offline and comes back online, when the cache has been updated, you can tell the user, hey, stuff has changed since you last came, and this is the new stuff. Same also goes with the news, yeah, the news blogging application you see on the left. There's a banner to the top of the screen that says the article has been updated, tap to refresh. Now let's look at experiences that, or visual cues you can give to your users to tell them that the application is offline and give them or guide them to options that are available when the application is offline and what they can do in that context. So here is an example of it. It's the same news application you saw earlier. This is the online version of it. So as you can see, everything is fine. The user is online. Although there have been updates, the user can choose to update the articles that have been updated or to continue reading. But the moment the user goes offline, they get to see this page. What's the difference between this page and the other? Did any of you notice the difference? What's the difference? The banner, right? Exactly. And that visually tells your users that something has changed. The banner is telling the user that the application is offline. So perhaps they've lost internet connection or they're out of range. The application is immediately telling them, hey, you're offline. And you see a gray banner to let the user know visually that there has been a change in your network connection. And if you take a look at the sidebar here, you can see that the application, although it's offline, it doesn't totally degrade the experience for the user. Some sections of news articles that require real-time information are grayed out and disabled. Something like business, for example, maybe the business has information about the stock market. That's data that is real-time, so that has been grayed out. But the user is able to read articles from other categories, like latest news, national, and the rest. So these are experiences you can build when the user goes offline. Instead of giving them a blank screen, you can actually use these APIs, looking at these techniques to give them a better experience for whenever they go offline. And something I want you to do when you get home, this is more of a homework. I want you guys to check out the background sync API. It's a really cool API that enables a lot of the experiences that you'll be seeing in this talk and in applications you see in production that work perfectly when they are offline. The support is not as good as the Service Worker API, but it's growing, and it's something you can actually start to build with today. And when you take all of what we've talked about so far, you take the manifest.json, you take the APIs we've talked about, the Service Worker API, the Cache API, the Background Sync API, IndexedDB, so many others, and you use these APIs in your application, you're able to build powerful progressive web apps. That is applications that work offline just as good as when the user is online. So really it's putting all of these together. And like I said, it's a DAO. You can choose to use specific bits and pieces of these tools and technologies in your application. You don't have to use everything. You use what works for your users and what you can afford at the time. And over time, you can increase the volume of the DAO to use more of these APIs in your applications. So let's change gears and let us build something live together. So there's going to be a demo showing you everything we've talked about so far in this talk so that we can put it into context and you see a practical example of it. So when you go home, you're able to remember what has been discussed and you can take these APIs to build your own apps. So the demo we'll be looking at is right here. So guys, take out your phones, scan the QR code, visit the page. You should type in a username. I'm just going to move out of the way so that you guys can get the application opened. I think the first thing you see when you have the application opened is you can enter in your username. So type in your name. Do we all have it opened? Can we see the application? Yeah, it's a game. It's the Dino game, which is also a bit of an irony because that game is the game you get to play when you're offline. But what you're looking at right now is an online-only version of the game. If you go offline, you can't play the game, right? So that's an online-only version of the game. And what we'll be doing for this demo is we'll take this application that works only when you are online and we'll make it work offline. So we're going to take an online-only app and we're going to make it offline by using the APIs and tools that we have talked about so far. Something I also want you guys to do is, as we go along building this application, play the game, and the person with the highest score should meet me after the talk. I have something special for you. So please, listen to the application, the talk. I want you guys to listen to the talk. But as well, the person with the highest score should see me after the talk for something special. So this is the application we'll be building, and it's good to know that you all have it opened. If you are curious how big the application is, this is a file tree for the application, and I actually think this is like a condensed file tree. So this is the game. By the way, I did not write the code for it. This is the actual Chrome dinosaur game that was taken from the browser and split across many files, just to give you an idea of how to take a larger application and make the application work offline. So it's a lot of code, and if you are interested in actually seeing the code for the application, you should go to my GitHub. It's megaconfident/Dino. That's where you can see the source code on GitHub. So the application has a lot of files. We'll take this application, we'll make it work offline, and let's get started. Is everyone ready? I can't hear you. Is everyone ready? I still cannot hear you. Is everyone ready? That's much better. So let's get started. So the first thing we'll be doing here is we'll be creating a service worker file. As you can see on the screen, there's a service worker file, which is on the other tab. But in this tab, in our JavaScript file, we want to register that service worker file. Like I said, the service worker is like a regular JavaScript file, but it runs on a separate thread. And you can't do like dumb things like manipulate the DOM, but it runs on a separate thread, and it is just another JavaScript file. So what you want to do in your main application JavaScript file is register the service worker file, and this is the code to do it. So you're simply calling navigator.serviceworker.register. You pass in the paths to the file. You tell it what the scope of the what path of your application is controlled by the service worker by providing a scope. In this case, I'm saying like all pages in my application should be controlled by the service worker of the sw.js file. And what we're doing here is just some login, housekeeping. When the service worker is installed, we print that to the console. When the service worker is waiting to be activated, we print that to the console. When the service worker is running, we print that into the console. And then if there are any errors, we log them out. So this is like standard housekeeping. The most important thing that's happening in this file is on line 4, where we are registering the service worker. And that's really all you need to take away from it. Then we should actually get into the service worker file. So this is the content of the service worker file. And like we mentioned, the service worker has 3 life cycles: the install stage, the activated stage, and the running stage. So when the service worker is installed, it runs the code on line 1. And what the code on line 1 is doing is this. Let's take a look at it. So line 2, you have self.skip waiting, which means that if the service worker is installed, it should not wait to be activated. It should become the current active service worker. That's because in production applications, you might have several versions of the same service worker running. So for example, you build an app with a service worker, it works offline, it's great. The users visited the app a week ago, and today you have updated that service worker by adding some new logic to it. That means the user who comes to visit it again today, in addition to the visit from last week, will have 2 versions of the service worker. But we want the user to use the current version of the service worker so that that controls the application, and that's what line 2 is doing. Then on line 3, we're basically telling the service worker to ignore all requests to /API. And can you guys remember why we're doing this? It's because the API contains real-time data we don't want to save in the cache. So we're telling the service worker, any request that goes to the API that talks to real-time data, please ignore it, don't touch it. But everything else, you can handle it. Then on line 4 and leading up to line 8, what we're doing here is we're creating a cache, and we're putting all of the static assets of the application in the cache. So the index.html file, the JavaScript file, the CSS file, the fav icon, literally everything you saw on that file tree, you want to put it inside of this list. The reason is because these are static assets that can be cached and should be cached so that the application works offline. And moving on line 13, when this service worker becomes active, we want it to control all open windows of the application. So we are saying client.claim on line 14. So when the service worker becomes active, it should just like take control of all open windows of the application. Then moving on to the most interesting bit here, that's what you have on line 26, which is the fetch event. And really, we've seen this code before. The code starting from line 17 to line 28, we've all seen this before. And the story is, if there is a fetch event happening in the application is trying to load a CSS file or a JavaScript file or another HTML file, this service worker is going to hijack that fetch event. And what it does is it checks to see if that resource is already in the cache. So if it's stuff already cached previously, like the HTML, CSS, and JavaScript file, it returns it directly. If it is stuff it has not seen before, maybe like a new image file that wasn't initially added on line 8, it's going to request it from the network on line 20. As you can see, it's going to make that request to the network, and in line 22, it clones the response and puts that response in the cache and returns the other copy back to the request, such that next time when that resource is requested, it's already going to be in the cache, and then there's no need to fetch it from the network. So really, just with 2 JavaScript files and maybe a few lines of code, we've taken this application and we've made it work offline. Would you guys like to see the new version of this application? All right, so let's take a look at it. So this is an updated version of the application. Please take out your cameras and visit the link so we can see what has changed so far. I think you have to enter in your username again because it's a completely different application. Do we have it opened? Do we have it opened? All right, so what I want you to do right now is go turn off your mobile data. You should have entered your username, by the way, but go turn off your mobile data and turn off your Wi-Fi connection and try to reload the application and tell me what happens. The first person to see what happens should let us know. What? It still works, right? Which is interesting. So we've gone offline. And if you have your previous tab open and you go to the previous version of the application, if you try to reload it now while you are offline, it doesn't work. But now we've gone offline, but the application still works just fine, like nothing ever happened. Isn't that great? So it means using these APIs, you can actually build powerful applications that work offline just as they would when they are online. So we can decide to end the talk here. Should we end the talk here, or do you guys want more? Should we end the talk here, or do you want more? You want more? Yes, we can actually do better. So let's do better. What we're going to do to make this experience better for users is we'll create a new file called the manifest.json. And really, the manifest.json is a configuration file that describes what the application is. So there are a few required fields, and these are all of the fields that are required. On line 2, you want to provide the name of the application. On line 3 to 14, you want to provide a list of icons. So the required icon size is 512 by 512 and 192 by 192. Then you want to provide a start URL, a display type, and we're setting this to full screen because the application we have built is a game, so it should take up the entire screen. And lastly, we are also setting a description. The reason why we are creating a manifest.json file is we want to take this application that now works offline, and we want to convert it into a mobile or native application experience. And that's actually possible. It's a website. You saw the link. It's just a website. But we can convert that website into a native application that works offline. It already works offline, but we can convert it into an app. And this is how you go about it. You create a manifest.json with these fields. Now, because we have a manifest.json and it's already linked to the application, the browser triggers an installation prompt. We want to customize the installation experience. So let's head back to the JavaScript file and write a few lines of code to make this experience better. What we're doing on line 7 is we're listening for that installation prompt. So when that prompt is fired, we hijack the prompt and we save it in a variable on line 3 that's called install prompt, and we display a banner. So we're displaying a banner to customize the experience for users so that they get to see the banner and then make a decision if they want to have this application installed or not. And on line 13, we are handling the use case where the user clicks on the banner. So when the user clicks on the banner, the onClick event fires, and then we actually go to fire the prompt we cached earlier, and the user has the application installed. The code you have on line 20 to 26 is stuff you've seen before. So if the application is offline, we display a little banner at the bottom of the page to let the user know that, hey, the game is offline, and the user knows that they can't access the leaderboard because the leaderboard requires the real-time API. And then on line 24, if the user comes back offline, we hide that banner. There's no need showing the banner to the user anymore. So let's step over to the service worker file. And we're making a very tiny tweak here. So remember, we've added a few new resources to the application. We've added the manifest.json file, right? And inside of the manifest.json file, we had 2 icons, right? So what you want to do is go back to line 9 and add the new files that have been added to the application. Because of space and to keep this snippet concise, we don't have everything that was there before, but these are the new files that we have created, so they should be added to the list of files that were cached previously. And you may have noticed what we have on line 1. There is a cache name, and the cache name is cache v2. So it means v1 is the old cache, and v2 is the new cache, and we want to do some cleanup. That's whenever the user gets to see this new service worker, the new service worker should know to delete the old cache and use the new cache. And how do you go about that? Take a look at line 20 in the activate event. On line 21, we're running a function called delete old caches. And this function is virtually going to delete every cache that is not v2. So that is going to ensure that now that we've made changes to the application, if the user comes to visit this new version, they won't be seeing old, stale files. They will be able to see the new JavaScript file, the new manifest file, the new CSS file. So anytime you have the static resources updated, you want to just go and increase the cache version from version 2 to version 3 and 4 and 5 and on and on. All right, so this is all the change we need to make to get this application, to make this application into a PWA. And let's do one final round of scanning. So open up your cameras, scan this code, and tell me what you see. Do you have it opened? Yes? If you have this opened, do you guys have the application opened? I'm not hearing anyone. You have it opened. You notice there's a banner, right, at the top of the application called install game. Click on the install game banner. If you've clicked on it, give it a second or two. It's going to get this application that started off as a web app installed on your phone. And remember, we already did the work to make it work offline. So it's going to virtually take this web app and make it into a mobile native application. Now go to your home screen or your application drawer. You should see the Dino game. Do you see it? You see it, right? So now you can go offline, click on the Dino game, and you should be able to enjoy it. And it feels like a mobile app because we have told the browser to make it a mobile app. Have you guys done it? You can see it works, right? Yeah, and it's really cool. So just with a few lines of code, we've been able to take this application that works only when it's online to make it work offline. So my time is up, and I'm just going to quickly wrap up this conversation. The code is on GitHub if you like to take a look at it. The browser does provide a lot of powerful APIs, and we've looked at just a few of them in this talk. So I'd like you to go back home, take a look at them in details, and figure out ways in which to integrate it into your application so that you can build experiences for your users to not only have the applications available when they are online, but also have a great experience when the application goes offline. All right, thanks everyone.